Okay, with limiting reactant problems, this is going to be whenever you start with two reactants and you want to see which one runs out first. So the reason the limiting reactant limits your product is that you run out of that reactant. For example, if I'm making water, water is hydrogen and oxygen. If I run out of hydrogen, I can't make any more water. Like making bologna sandwiches. A bologna sandwich, if I'm making it with just bread and bologna, if I run out of bread, I can no longer make bologna sandwiches. I just have bologna. So what you do is you just want to see which one's going to run out first. Sometimes they're really easy, like this setup. You're going to need a balanced equation, so I'll do that first. I'll put this positive barium with this negative sulfate and this positive aluminum with this negative acetate, and I'll say barium is a 2+, sulfate's a 2-, SO4 2-, so their charges balance. And then the aluminum is a 3+, and the acetate is a 1-, so I'm going to need 3 acetates. So CH3, CO2, 3 of those. Okay, so now I want to balance the equation. I have, let's see, 2 aluminums here, so I'll put a 2 here to have 2 aluminums. Now I have 6 acetates, so I'll go ahead and I'll put a 3 here. 3 times 2 gives me 6 acetates. 3 bariums here, so I'll put a 3 here. 3 bariums, 3 sulfates, and I have 3 sulfates. So I've got my balanced equation, and my equation relates moles. It tells me that 3 moles of barium acetate react with 1 mole of aluminum sulfate. Alright, so if I have a mole of each, right away I know that I need 3 moles of barium acetate, for every 1 mole of aluminum acetate. So clearly I don't have 3 moles, I don't have 3 times as much. This is my limiting reactant. I'm going to run out of it right away. And the next one, same thing. I need 3 moles of barium acetate for every 1 mole of barium acetate, so again, it's my limiting reactant. As soon as I use up a third of my moles of aluminum acetate, a third of a mole, I'll use the entire mole here. So when I use up 2/3 of this 1 mole here, I will have used up 2 moles of this guy. So, and this is really, really easy. Sometimes you can look and just see what the limiting reactant's going to be, but sometimes you have to do some calculations. So we have to, sometimes we'll have to use some dimensional analysis. We just use the mole ratio. We just saw in the last one that for every 1 of these, we have 3 of these guys, so I'm just going to put that mole ratio in. Okay, so in this case I have 0.53 moles of the barium acetate, so CH3CO2, and I know for every, I'm going to look at how much of the product I can make, and let's see, did I go all the way to moles? I did not. That's great, it's much faster this way. So here, we already saw that this makes 3 moles of barium sulfate. So I'm just writing part of the balanced equation from the problem before. I have moles of barium acetate here. That's what has to go on the bottom, is barium acetate. So, and then I can say for every 3 moles of this, I'm going to make 3 moles of the barium sulfate. So, oh, I've been to the office, sorry.
Oh, it's the office.
It's okay. See you, Chelsea. And Chelsea. Okay, so we're going to go from moles of the barium acetate to moles of the barium sulfate. And I can see that it's 3 to 3. So I'll say 3 of these for 3 of these. So if I had 3 moles of barium acetate, I could make, 0.53 moles of barium sulfate. All right. So that's how much barium sulfate I can make with the barium acetate. Now we'll try and do the same thing with the aluminum sulfate. So let's see, I have 0.17 moles of the aluminum sulfate, Al2SO4. And I can say for every 1 mole of this, of the aluminum, I can make 3 moles of barium sulfate. Bells ringing, somebody's walking on the roof, people knocking on the door. I used to come in on the weekends to do this, but I'm not going to do that anymore. That's silly. Okay, so I've got 0.17 moles of aluminum sulfate. For every 1 mole of this, I make 3 moles of that. So I have enough of the aluminum to make 0.51 moles of the barium sulfate. Okay, so what I just did, I found out how much barium sulfate I can make with each of the reactants. The aluminum makes less, and that's because I run out of sulfate as soon as I've made 0.51 moles of barium sulfate. I can't make any more, so I can't get up to that 0.53. Aluminum sulfate's my limiting reactant. This is how much I could make, the theoretical yields. All right. So now if I had grams, if I have grams, I have to turn that into moles first. So here we have 15 grams of barium acetate. CO2. An acetate is CH3CO2 with a 1 minus. I'm going to go from moles of the barium, I'm sorry, grams, because that's what I have is grams. So grams of the barium acetate. I need to find out how many moles that is. So I'll use the molar mass and I'll find out how much each mole weighs. From there, I will know the moles of the barium acetate. And I'll go from moles of barium acetate to moles of barium sulfate. And then, this is seriously the most disruptions ever. It's like my 75th video. It's kind of funny. Okay, so I'll say 1 mole of barium acetate has a molar mass of 255.42 grams, and that there are 3 moles of barium acetate for every 3 moles of barium sulfate. And when I go 15 divided by 255 times 3 divided by 3, I end up, let's see, oops, and actually I went all the way to grams in this. That was silly of me, but I can do it. It was silly just because it's one extra step and it was unnecessary. So for every 1 mole of BaSO4, I would have had 233.39 grams of barium sulfate. All right, so I have enough barium acetate to make 14 grams of barium sulfate. Let's see how much aluminum sulfate I have, or how much barium sulfate I can make with the aluminum sulfate. There's 5 grams of aluminum sulfate. I have grams of aluminum sulfate, so that goes on the bottom. Whoa. Okay, so I'm going to go from grams to moles. I'll find out, using the molar mass, how many grams there are in 1 mole of aluminum sulfate. And then I know that there's 1 mole of aluminum sulfate for every 3 moles of barium sulfate that I make. Again, just whatever units here goes down here. So I'm going to go from moles of aluminum sulfate to 3 moles of barium sulfate. And then let's just compare how many grams of each I can make. So for every 1 mole of BaSO4, because that was the unit I had in the step before, I have 233.39 grams of BaSO4. Okay, so based on the aluminum, when I type this in, when I go 5 divided by the mass of this guy, which was 342.14. So 5 divided by 342.14 grams times 3 times 233.39, just multiplying anything that's on top divided by anything on the bottom. I have enough of the aluminum sulfate to make, 10 grams of barium sulfate. All right, so the barium is going to be the excess reactant. That means my aluminum sulfate is going to run out as soon as I make 10 grams of barium sulfate. So the aluminum is my limiting reactant, and 10 grams are my theoretical yield.